I'm in Ashland, Kentucky, out at Valvoline's Engine Oil Lab. Why am I here? Oh my god, it's probably one of the geekiest, coolest reasons. Of course, my damn gimbal has to break right as I'm about to do this, so you guys have to pretend that there's some sort of really cool intro shot. The sun's coming up. I'm packed light. Oh my god, this is fun. We're filming this video, right? And they're only supposed to be like 3-minute videos. You'll probably see them soon enough on Valvoline stuff. But it's a bummer that we can only film 3-minute little quick segments because you don't realize how much goes into making those marketing claims. If they're saying 50% more wear, you're like, okay, sure, 50% somehow. No, there's actual tons of data. The engineers, of course, are like, oh man, it does way more, but you can't say that. There's so much more involved, but the amount of detail and geekiness, the amount of engineering that goes into this, it's there. For something like this, it's very impressive. Of course, as we end up shrinking modern engines down, they're all turbo. The intercooler right here is all maintained. The temperatures are all controlled environment, and they can adjust it, not just control it, but like, simulate the engine up and down, different temperatures, all of that, really just to make sure that the little timing chain that's hidden behind that front cover stays safe. This is super exciting. And we filmed a formal part about how this entire engine lab works, but I'll be honest, those short videos aren't going to do this place justice. We're testing a variety of things. For me, hearing the words chain wear test doesn't mean that much, but what it is actually doing, the chain and the way that a chain wears is indicative of a lot of other things that don't wear nearly as fast when your oil isn't that good or you've neglected to change it. One of the other tests back here over behind me now is the heat test, and I didn't realize that when you have oil and you overheat it, I thought it was like okay, I made a mistake one time, my bad. I didn't realize that you actually do lasting damage. If you go really crazy, you start really breaking down the oil and causing some serious deposits. So a lot of things that I didn't understand, it's really fascinating to see it here. All the marketing aside, this is the only oil company that has a dedicated engine lab. That's not like a marketing thing, that's a real world experience. So they're actually testing this stuff, and it kind of prevents people like me from testing it separately. They know what that oil is going to do because they've already done it here. They've punished that oil and they've formulated it to handle what they're expecting. It's really awesome stuff. Not only are they testing oil, but they're also testing coolant. Controlling the temperature of the coolant, but then beating the hell out of the engine lets them see if the coolant leaves deposits. In the turbo, in the head area, all tells you whether or not the engine has seen additional deposits just because of the coolant. That's insane to think that all of that's being tested here. So this place that I'm at is Valvoline's Engine Lab. And of course, places like this are sometimes hard to see the beauty in how crazy this looks. It looks like work. It looks like a serious place, and it is. But the amount of information that you can get from a place like this is mind-blowing, especially for somebody like me. Now, they're filming formal videos to this, but what I wanted to show you guys was behind the scenes, and the engineers here are genuinely us. Like they talk forever because they're so passionate about something so specific. So it's kind of funny because the videos are supposed to be 3 minutes long, and here we are wanting to talk about the specific aspect of the viscosity of oil when it's at high speed and high load versus idling. You're actually working more on wear friction modifiers and film surfaces. Like all that stuff just starts to blur, especially to the guys and producers here. Behind you is the coolant testing system where they're actually burning the engine down and just seeing if the coolant leaves any sort of trace deposit throughout the engine, the turbos, everything. It's really crazy there. But the one behind me is really one of the coolest tests, and that is a test that tests wear. So they've got a timing chain. The timing chain wear doesn't sound like a cool thing to me, but it really is. The timing chain is one of the easiest parts to test and measure whether or not wear is occurring in the engine. And of course, as you know, oil makes a big difference in that. Just really wild things that actually go into how oil works in there, not just, okay, cool, it lubricated the engine. You know what's really random to see at an engine oil lab? Electric vehicles. This is something that's up and coming, something very fascinating that Valvoline is once again kind of one of the first to making new standardized testing for a vehicle that is also very new. So it's neat to see that innovation is always happening. They've already got amazing products, but they're always pushing them further, and that includes vehicles that don't even have gasoline in them. The entire drivetrain is going to have some sort of liquids, whether it's going to be like a transmission. These also have a very weird way of doing that, but the whole driveline needs lubrication, but there are other special products that are needed to make these things last, and that, once again, where Valvoline is pushing the envelope and making sure that there's even some potential for a standardized test for that. Not only are they testing OE type of electric vehicles, but they're also having fun making their own as well. It really is just such a new field. You've got electric power, which is inevitable. There's a massive part of the future right behind me, and Valvoline's right on the cusp of it. This test is actually probably the one that blew me away the most. It's trying to test for fuel economy. It's a standardized test that Valvoline made years ago that they've continued to improve, obviously, but with CAFE laws and everything requiring more fuel economy, this matters more. Now, cool, I don't care about fuel economy whatsoever, but you know what I do care about? What fuel economy actually means in the engine and engine oil. That's all about the lubrication, all about the friction. If there's more friction, lower fuel economy. It has nothing to do so much with the engine as much as it has with the oil. Less friction means more power to me. This test is trying to simulate like long-term life cycles, like oil changes and all of that, and standardize it, not allowing any variables to change. That way when they're testing, while the engine lab behind me is focusing on making tests that age oil quickly and accelerate and simulate tons of miles on an engine, the one behind you is actually testing their new product, the extended protection product, real time, and they're honestly going until something fails. This is their Ashland oil lab. We're now going over to Lexington to see their other one. So when I made it to the oil lab, not the engine lab, but the oil lab, I wasn't able to film anything, but I can talk about what I saw, at least not the super secret stuff, but I will tell you a lot of what I have now learned that is mind-blowing. There are 3 major points to almost every single type of oil that you buy. There is the first thing called a base oil. It's normally clear. It does base oil. It's just the raw material needed for that. Second thing is all the additive packages. So in this VR1 2050, what really makes it a solid VR1 is the ZDDP, the zinc, the phosphorus, and the other detergents and whatnot that Valvoline puts into that oil specifically for, in this case, racing applications. So that's the second major part of oil. The third part is actually the 2050. If you have a base oil, it's just 20 weight, 40 weight, 50 weight, whatever. But when you have this in there, it allows you to extend the range of the oil. So cold startup and then high heat operation all in the same product. That's why we use 2050. If you're gonna run just a straight oil, well, the concern you'd have is either A, that your startups don't get the oil out through the entire engine quick enough, or B, that when it gets really hot, the oil becomes too thin for the high heat operation. So this range here is a third part of the core product. The beautiful thing here is that they have all these excellent additives that are for race engines. But before we talk too much about, oh, could you use thinner oil or thicker oil, let's talk about what's actually happening in the system of a rotary engine, why oil is so critical, and how to really think about what matters with oil. So we'll start here. This is the four-rotor that raced Ken Block's E-shaft. So this is where all the power is transmitted out to the wheels. All 4 wheels basically connect right here and out to the rest of the car. So this needs to make power and turn it into a spinny motion. Simple enough. It's a very odd thing, but I've even brought this 2-rotor E-shaft here to show you an even simpler example. And you can guess, here, 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 and here is where oil is separating this from the other metal on the other side. On this one, here, 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 here. This one's special because it's actually a ball bearing, but all the rest of them are oil fed. You see how nice these look? I've even had oil failures where my oil belt fell off, and yet the Valvoline protected it in those extreme situations. This one, you can actually see much more wear, and this isn't a race engine, it's a generic 2-rotor, and it wasn't blown either. It's been ran for a while, and it still had, what you can see is a little bit of interesting wear pattern there. So if those 2 E-shafts are good, this is one that suffered a catastrophic failure. Let me show you how oil runs through a rotary engine so you can understand the key components of oil that matter so much on this. You hear a lot of misinformation. Let me dispel a lot of those myths. So, right here is what's called a stationary gear, and it's stationary and it's a gear. That gear is also on this side of the rotor. Those 2 connect in, and now the rotor can only do a very specific shape. It's like, you guys remember, not Etch-a-Sketch, the spirograph, where you put the pen down? That's exactly what's going on right here. Your pen can only go in a certain shape, and in this case, it's an epitrochoid. It's a wild-ass name. When one spins once, the other one spins 3 times. It blows a lot of people's minds that when the E-shaft, imagine this is where all the power comes from the clutch to the back of the wheels, goes out there. This is all the power being transmitted to the engine. So when this piece is spinning, watch what happens. This piece spins much faster than the rotor itself. And that's because of that gear in the background and the shape of the engine overall. So what happens is every 3 times this spins, the rotor only spins once. There's a reason why rotor engines can rev so high is because the spinning part is only spinning at 1/3 of your RPM. So if this is at 9,000 RPM, whoa, going nuts, the engine's only spinning at 3,000 RPM, which is why I argue that not being 100% balanced actually still works considerably, because that part isn't as critical. Balancing the E-shaft, I think, is the more important part. Oil is managing failure from 3 points, and you can see 2 of them already messed up here. This is the part that holds this to the engine. The E-shaft's floating in space in the engine. The second one is the oil protecting the rotor. And then the third one is the gear itself. The tips of this gear touching each other. Those are metal on metal contacts. Those 3 things are extremely critical, but it's not as important as something that everybody overlooks when they're not familiar with building rotary engines. And that is oil used as coolant. Yes, the oil system stays within these rings right here. So oil stays within these oil control rings. And that's how you can oil this, but not get it into the engine. The oil ring is sitting out here doing this, holding the oil inside of this path right here. But imagine if the oil's inside of there, obviously that means this ring's covered in oil, it means this bearing's covered in oil. That also means that this whole rotor is filled with oil. That rotor gets very hot, and there is no way to lubricate any of these outer pieces without adding oil to your premix, to your fuel. But the oil inside of here can only stay in here. That oil is absorbing the heat that is being placed on the rotor itself here. So when there's heat, went from this, we'll call it explosion, boom, explodes. That heat, a lot of it goes out the exhaust, a lot of it goes into the coolant absorbed on the heat here, but this face is only cooled by the oil inside of this rotor. So one of the most critical things that rotaries need, that pistons don't as much, is that the oil flowing through this rotor has to cool and extract heat out of it. That is something that Valvoline does a phenomenal job at. And we're talking about, look at in those 4 tests, heat, contaminants, all those different tests that Valvoline tests for. One of them is very much just heat. Higher heat causes oil to break down quicker, and Valvoline tests for all of that. And in my engines, obviously we try and keep the heat to 185 degrees between both coolant and oil. You don't know how hot it is inside of the rotor itself. You're measuring the temperature of the oil coming back into the engine. So the oil leaving this rotor and then dropping down to the oil pan is so much hotter, and that is the actual heat that the oil has to withstand. Those 4 components all come from one place on the engine. If you see my engines, you'll see that the oil comes from up here, and it travels along the inside of this right here to the bearing there. Awesome. Just makes sense. There's a bearing right there, a hole where the oil comes in, and then it sits inside of this trough, and it goes from that center of that trough outward. This is a used bearing, and it shows what it looks like when you start running through the tin. You start getting into the copper colors. It now looks like this. So now you can see this center area isn't really making metal on metal contact. That's why you get this shape on used or broken rotors. Oil pressure then is sent to this whole wide area, and that's how you get this to run without breaking. But it gets crazier than that. This hole right here takes a percentage of that oil that's now being pushed onto this bearing, and it's actually pushing it inside of the E-shaft. So the center of the E-shaft is filled with that oil. So it comes in here on a larger engine, say like a 4-rotor, comes in here, 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 and here. It travels through this whole thing, and they all meet up. It's all one big channel. But then it sprays through these holes here. Not only does the oil come into the engine and start lubricating the overall bearings, it then goes through the E-shaft and goes to each of the rotors. So now the rotors are actually being sprayed from the center inside there, and that's why you don't see any holes on any of this bearing. These bearings don't get holes because they're not giving oil, they're taking oil. And then, if you're wondering, well, where does the oil go from there? It sprays and pours out of the sides here. The high pressure area is right there, and it drops into the rotor itself. Further yet, to guarantee that happens, look at these little things here. These little super soakers are actually spraying oil onto the gear right here. So these little things are spraying oil into the rotor here. So you've got basically a bonus helper spraying it into the rotor. All of that then collects inside of here, goes through here, and then it actually drops out the bottom down here. Once it's gotten into the rotor, and then that pressurizes and fills up and flows through, it actually goes outside of this gear, so the gear gets lubricated, and then it goes into this channel down here. You can see the hole from an angle right there. That hole right there then allows oil to drop down into the oil pan. That's the circle of life with a rotary engine. You can't skip any of those steps. It's a linear process. You're talking about tons of heat being absorbed by the oil, as well as just weird tolerances of all this. So a lot of people are like, well, what if I use thinner oil? What if I do all these other things? On top of all of this, what you have now going on is you have fuel that's sitting inside of here. You know, this combustion chamber is sitting right here. Fuel will escape past these side seals, even if you haven't properly spec'd to Mazda's specification. There's still a 3/1000th of an inch gap right here, and it goes into here, and then it can get past the oil control rings, and you get fuel into your oil. You ask me, why do you use 2050? Well, the 2050 actually helps for the fact that fuel will dilute your oil over time, especially with racing, and then now you have thinner oil mixed with a percentage of fuel. And you need the additives that are in oil like this to also kind of neutralize all the stuff that's inside fuel. Because what's fuel good at doing? It's good at breaking down oil. You have a lot of things on a rotary engine working against you. The engineers at Valvoline have taught me a lot of things. I was worried about how many thousandths do you clearance these? Like, okay, you know what, I want this to be super tight so that way I get high oil pressure and that it floats, and no. One of the bigger things that people overlook on rotary engines is the flow of oil out of the engine. That not just pressure, because we can get pressure, but you want to flow a lot of oil to absorb a lot of the heat on your race engine. So here's where Valvoline's Oil Lab blew my mind even further. They had sent me what looks like urine sample things. But you put oil inside of this. Now there's a company like Blackstone can also do it on a private sense. But you put your used oil inside of this, and it looks like you go get it developed overnight with an old canister of film. And then they analyze the material in it. They analyze all the elements, and they analyze all of the other contaminants that can be in it. And so if you took one of these, which these are all the ones for the Patreon guys, they're being shipped out now. If you took one of these, which is the oil from the Unicorn race and all the dynos and everything like that, what you would find is that almost 100% of the zinc and phosphorus was still in the oil. So that oil was still, I mean, you could straight up use the oil that came out of that. Even though I did all that high horsepower stuff, the results speak for themselves. There's not any wear. There's not any significant wear. There was like 2 parts per million, maybe 1 part per million of iron, which this steel is primarily iron. Essentially no iron in the oil. There was the same number of parts per million that you get that is advertised. There was a slight bit more of zinc and phosphorus. So all those really soft metals that are used to protect metal on metal wear, they were all still in there ready to go. And there was some dilution of other chemicals, but that's, like I said, blow-by causes all of that. So when you're analyzing your oil, you're kind of thinking at like little loading bars of how much of your protective materials, the zinc and the phosphorus, how much was left in that, how much copper, tin, or iron is in the oil, because it shouldn't be. And that's indication of extreme or maybe even possibly normal wear on your engine as you go. Fortunately, their engine lab showed me all of that. They showed me what to look for. The thing I'm going to be focusing on next while I build my own engines is all about oil flow and oil temperature, not the oil going in. We all know that that's reasonable temperature, oil, whatnot. And of course, pressure going in, fine. Bearing clearances, fine. You can look at Racing Beat for, oh, hey, you know what, go 3 to 4 thousandths of clearance for racing engines. Cool, that's all fine. What I want to focus on is the amount of oil flowing through the system, keep those rotors cooler to prevent pre-detonation, and also focus on the heat of that oil. I think that if we get more flow going successfully without diminishing pressure, we can also get all that heat out, which also means that the oil won't degrade as quick, because when you're talking about over 300 degrees Fahrenheit, you're damaging any oil that comes into this engine. This stuff will last longer than almost all other engine oils, but you're still pushing oil way hotter than it should be. If it's a race application, that might be by intention. You know, you save weight, get a little crazier. But if you're talking about a person that's trying to build a car in the garage, I want to show you, hey, this is the temperatures that we should be expecting, or these are the modifications you should do to your oil system to maximize flow and longevity of the engine. What I'm going to be doing on my billet engine tests is put a sensor into the oil pan, not for the oil pan temperature, but the temperature of the oil that is coming hot off of the bearings and the E-shaft, that when as soon as it comes down, I want to capture the temperature of that oil, especially in hard runs, to see how hot the rotors themselves are, and to see if we can do things to cool that down, or at least just find the temperature range that they're best at. The hotter the rotors are, the more that you could have pre-detonation, the more you could have shit that sticks to the edges of the rotors. You can see that the 4 rotor is doing very well with E85. This is the actual rotor from inside of it. Bearings are great, and there's no real contaminants on the edge of the motor, but you can see a little bit of stuff going on right there. Thankfully, the side seals prevent that from going any further. I cannot thank Valvoline enough. If you guys know me, even a fraction of my personality, you know that I was the one begging to go to the engine lab. This was all extremely geeky, but it was what I want to know because I want to build a better engine. And these things matter. Instead of just the generic, hey, what oil should I use? Or, hey, I think Valvoline's the best. Here's why. They can show you exactly why. And it's facts. It's not me pitching something. It's me showing you or educating myself and you all on why it is so amazing.